Hey everybody, welcome back from lunch. Thank you all for joining us this afternoon. We're going to kick off the first session after lunch with Grant Dasher, who has one of the coolest titles I think I've seen, Architecture Branch Chief at CISA. He's going to be talking about some of the latest and greatest things that he is seeing. So Grant, thanks for coming today.
Okay, thanks a lot, Zach. All right, hey everyone on the stream. My name's Grant Dasher. I work at CISA, and I always stop with CISA, not CISA. CISA, the Cybersecurity and Infrastructure Security Agency, is a component of the Department of Homeland Security focused on reducing risk to the nation's physical and critical infrastructure. In that role, I'm here to talk a little bit today about a couple of our initiatives in the authentication space, in the cloud security space, and more broadly, our Secure by Design initiative. So I want to start this talk with a tale of two stories. Now, both of these stories came out around the same time last summer, and I think they're just an illustrative example of some of the challenges that we face in the cybersecurity industry and in the technology industry more generally. Everyone will remember the submersible, right, that crashed last summer. Well, it turns out one of the reasons why it crashed is because it was made out of carbon fiber and not titanium. And most submersibles are made out of metal like titanium. Carbon fiber has a lot of great material properties. My wife is a materials engineering professor, so I really like this example. But has a lot of great material properties. It's very, very strong against tension, but it's very weak. Or not weak, but when you're pushing it, right, the fibers, they are not resisting you, you're really fighting the epoxy. And so it's much weaker under compression loads. And it turns out when you're deep underwater, lots of compression loads, some cracks, right? So the New York Times published this wonderful expose, which goes really deep into the engineering issues that led to the failure of this submersible. Fascinating article if you're a nerd like me and you like this kind of stuff. Around the same time, China-based hackers compromised Microsoft's core digital identity systems and used that to exfiltrate email from the Commerce Department and the US State Department, among many other actors. There was a Cyber Safety Review Board report written around that this spring, which describes in quite a bit of detail what happened. But in any event, the press coverage basically just said that China hacked the State Department. Didn't really talk at all about why, any of the specific sort of issues that led to the failures of those systems. And this is a more general problem, right? There is an expectation in, for example, physical engineering where like things shouldn't just implode, like they should be safe. They should have certain engineering properties that are necessary for safety. Airplanes should not just fall out of the sky. That expectation isn't there, really, in the cybersecurity industry, and it's not there in the way that we talk about the problem. And that's really why I'm bringing these two articles forward, to sort of just contrast the way that people talk about this. And there's differences, we'll get into some of them, but I think it's a really interesting and illustrative example. So another example of an accident, this one is from aviation. There was the plane that caught on fire in Japan. And there's this great quote, and talks about how modern aviation safety records are written in the blood of others who haven't been so fortunate. Accidents become lessons which are shared across the industry so crew can all be better at their jobs. And really the important thing there is a culture of shared learning and knowledge. And we do have that to some degree in the technology industry, but I don't think it has infused into the cybersecurity community or into the notion of making our technology products safer in the way that it has, for example, in the aviation industry. Unfortunately, the stakes are really arguably, in fact, I would say just as high. A lot of times people talk about cybersecurity as an economic problem, and it is an economic problem. Ransomware is a significant economic drag on the economy, but there are real, deeper human effects. That's certainly true. For example, we saw that with the Change Healthcare brief, and some research that was done that showed that there were actual material impacts on patient care that were downstream of a cybersecurity incident. But the more extreme example is this. This is from the unclassified Office of the Director of National Intelligence Threat Assessment from January of this year. And it says that if Beijing believed that a major conflict with the United States were imminent, It would consider aggressive cyber operations against U.S. critical infrastructure and military assets. Such a strike would be designed to deter U.S. military action by impeding U.S. decision-making, inducing societal panic, and interfering with the deployment of U.S. forces. And this is just to say that, according to the assessment of our intelligence community, there is a non-trivial risk, and this is a scenario that I think is a real scenario. It's certainly a scenario that no one wants to happen, but it is a scenario that is on the table in many respects. Aggressive cyber operations disrupting critical infrastructure and inducing societal panic. So the stakes here from a safety point of view are significant. And I would rather prepare for those in advance than have to sort of pick up the pieces afterwards, at least as much as possible. So why are we here? So our director has advocated for taking a safety mindset to the development of technology products, including digital identity systems, and has advocated for a shift in attention from the vendor community on the introduction of technology that is fundamentally more secure. And I think a lot of the work that's being done here involving passkeys and FIDO is an example of what we're talking about, and I think the adoption that we're seeing is great. It is driven, as was mentioned in the keynote today, in many respects by simplifying things and making things more efficient, and that's great when that aligns with security, but we are also improving the safety baseline, even if that's not the primary reason why adoption is happening in many places. So I want to take some of those lessons from safety engineering and apply them a little bit more specifically to authentication and cybersecurity. And this is really the perspective that we're trying to advocate for at CISA, along with other parts of the US government, which have slightly different versions of this, but the same basic theme. So in safety engineering, you have a process, you measure the defect rate, you analyze to understand the defect causes, you engineer process optimizations to eliminate defects, then you iterate and repeat. So how do we apply that concept to authentication, for example? So, you can measure, right? What percentage of initial access attempts on my network are due to phishing of credentials is a measure that is aligned with the threat. You will likely find that this number is quite high. Then you can analyze, right? Credential phishing is caused by weak authentication controls. That's probably not a surprise to anyone in this room looking at the audience, but in the broader cybersecurity ecosystem, I think that probably does come as a surprise, right? There is a lot of noise in the community around, other things, right? And part of this is definitions, what is phishing, what is not phishing. I'm going to put all of that aside and say, capturing of credentials is fundamentally caused by weak authentication controls, which is a technical problem that we can solve, and we can engineer solutions such as deploying phishing-resistant authentication, such as FIDO, passkeys, PIV-CAC, and make the problem go away. And companies that have deployed these technologies have in fact seen that, right? The problem just goes away. Now, it's not to say that threat actors don't pivot. They will find other places to attack. But when you can close a door this dramatically, it really should be a clear engineering win. And this is an iterative process. So then you move to the next problem, you apply the same methodology, you keep going. We can do the same thing for cross-site scripting. Why is it that we still have templating languages that we're using today in new software that doesn't exist that do not prevent XSS by construction? Good question. SQL injection, right? The parameterized queries have been around for decades. Why is it that new software is getting written today at large scale that concatenates strings to build queries? Memory safety is a more challenging problem. It's much broader scope. There is a lot of legacy complexity, certainly. There are certain situations where the tools don't exist to do that. Memory-safe languages in embedded systems, for example, is still very early. But we can apply this same conceptual model. We can iterate. We can solve these problems one by one by one by one and improve our baseline. And we think this culture of product development through safety engineering is a valuable one. And it's something that we are continuing to advocate for at CISA. So that's one of our initiatives. I do think this is not analogy doesn't translate identically. So in most physical engineering situations, the adversary is gravity or other laws of physics. In cybersecurity, we face actors who can adapt and react, so our models have to be more conservative. We have to make more assumptions about what the adversaries can do. They might get creative and work outside of our model. Gravity is in many respects not that creative. But I think that the same basic set of concepts do translate to large part. And I'm not the only one who thinks that. There are a number of people who have applied these concepts in different ways. There's a spectrum of views outlined here. On the one hand, Kelly Shortridge has a book which basically argues that we should adopt change and we should build systems that are able to change really quickly and adapt that as a philosophy for driving security outcomes and sort of live the change as the way to drive security. On the other end of the spectrum, Ron Ross at NIST has a document which talks about how to translate more directly concepts from aerospace engineering to the construction of what he calls trustworthy secure systems. We would call them secure by design systems. There's some nuanced discussion there about the right terminology, but it's the same basic conceptual idea. And then in the middle, a number of authors from Google wrote a book around essentially applying this concept of platforms, right? How do we make platforms from which developers will emerge with secure software by, for example, having secure default identity systems in the platform, secure default programming languages, secure default templating libraries. All these pieces can be composed and more secure software will just sort of emerge out of the construction of those security controls into the platform in which people are developing, into the developer ecosystem. And so all of these share different elements of the same core idea. They have differences, but they're all sort of fundamentally adopting this construct of applying safety engineering to software construction that we think is very valuable. So in this general space of cloud security or identity, you talk about shared responsibility. What do we mean by shared responsibility? So I want to talk a little bit about different sort of frameworks and guidance. Tom had a slide earlier for those of you who saw his talk about all these different layers of guidance that approach. This is a very simplified version talking about a piece of that. So at the top you have sort of high-level frameworks like the NIST cybersecurity framework, which are comprehensive, flexible, and outcome-based frameworks for thinking about a cybersecurity program at a macro scale. CISA has published a document called the Cybersecurity Performance Goals, which are a little bit more specific and prioritized. They are not as comprehensive as the CSF. They are more narrowly constructed, but they are high-impact things that you as an organization could do to materially improve your cybersecurity posture. And then at the bottom of the ladder, we have step-by-step configuration, guidance, and measurement tooling to, for example, tell you exactly which switches on that very complicated page of switches in the management interface to your SaaS product you should turn on to have a secure or more secure outcome. And I want to talk a little bit about one of those initiatives in that bottom right corner, which is the Secure Cloud Business Applications Initiative. This is an initiative that I worked on quite a bit at the creation of it back in 2021, and it's sort of blossomed and grown there, and I'm very proud of this one for us as an organization. But what we did is in the aftermath of the SolarWinds attack, we deployed incident response teams at all these different federal agencies, and we observed a divergence in the way in which they were configuring their SaaS products, in particular their core business collaboration tools. And that's not really surprising, right? These are different, in many ways, different government agencies are almost like different companies. They have different missions, they have different people, they're subject to the same sort of high-level policy requirements, but maybe interpreted in different ways, different constraints that they're operating under in terms of resourcing or mission constraints. But we did see that there was an opportunity to sort of up-level security baseline across the board for high-impact business collaboration technologies like Microsoft 365 and Google Workspace. So we started this project to really, at a very granular level, outline what exactly is our opinion in terms of how we want these products to be configured to balance security and compliance to the various, compliance obligations that these organizations have. So our friends at NIST have a comprehensive control catalog of controls that's really meant to apply to any system with some tailoring. But conceptually, at the level of I'm an admin and I'm trying to configure this product, what should I do? So we looked at that in some detail and we created this project. It consists of a number of policy baselines, which are statements for how you should flip these switches in these products in a way that is sort of our opinion on what is the secure configuration for these products. to meet sort of our interpretation of the threats that the government faces and the compliance obligations that it faces as well. These are not mandatory, right? These are our opinion at this point on what you should do. We have, of course, implemented them ourselves in our tenant, and we've taken feedback from a number of other agencies in the civilian federal government on these baselines who have then implemented them in their tenants. But fundamentally, they're us expressing an opinion on how to configure these products in a way that is, relatively secure against reasonably foreseeable threats. But the most interesting thing that we've done is on the automation side. So we actually wrote a tool that connects to the tenant, downloads all the state of the tenant, and runs evaluation of the state of the tenant against our policy baselines. And so it will create these reports and underlying data that says exactly how your tenant is configured versus the configuration standard that we have defined in the baselines. And then we can aggregate that data across multiple agencies and use that to drive measurement and monitoring and change and all of those kinds of things. But fundamentally, it's data collection. Under the covers, this is implemented using OPA Rego, which I've become a great fan of because it's quite expressive. It was a little bit of a mind warp for our development team when we proposed that they use that. They weren't familiar with it, but now we have people giving talks about how to use it and stuff. So they've gotten very excited about it. It's pretty nifty technology. But this shared responsibility model only takes you so far. And a core tenet of our sort of philosophy of software that is more secure by construction or software that is secure by design is to move beyond strictly this understanding of allocating risk between different players in the ecosystem, and how do we drive improvements in the defaults so that everyone can benefit, not just the most sophisticated players, for example, who can really dive into the details of something like Scuba. So, we think guidance and best practices are very valuable, but there's also, frankly, a lot of it out there, and it does run up against limits in terms of resourcing for implementation, drift, complexity. Managing all of that is non-trivial. Some things do require customer action, right? If you want to roll out FIDO in your organization, you want to roll out PKI in your software workloads or your smart cards or whatever, like that is not something that can be done by your vendor without you doing some action. It has a touch on the end user. You have to have them participate in some sort of an enrollment ceremony, for example, or other means of distributing identity. But many things really shouldn't require nearly as much customer action as they do. So for example, people patch constantly, month after month after month. And when you look at this from like what are the causes of these CVEs, what are the causes of these defects, and you rack and stack them, it turns out that the causes aren't changing. The causes 10 years ago are the same as the causes today, and many of them are the same as the ones that I said that have mechanisms that just eliminate them. So some organizations have eliminated entire causes from their ecosystem. Others have not, and there are lessons there for adopting that and really materially reducing the rate at which we need to patch these vulnerabilities. And so that's something that we're trying to help facilitate knowledge sharing. And every time anyone gives this talk, people will say, but it's an economic problem. Yes, it's an economics problem. There's economic incentives, there's demand, there's all of these things. That said, fundamentally, I do think we can make progress, without massive shifts in, for example, the way liability is allocated in the industry or some of the other things that have been proposed at the national policy level. A good amount of this can be done just by people who are writing this software, making changes that are low cost at the moment in which they make it, but massive costs down the road, right? There is an element of this which we can sort of work out together as a collective community that's creating technology products. And some things just need to be easier, right? So, security UX is notoriously complicated, right? There's lots of settings, there's lots of switches. What does this do? What does that do? It's not clear. Better defaults, better profiles, better ways to group relevant configurations together to make them easier. Tom mentioned earlier this paper that we wrote with our colleagues in the ESF, which is sponsored by NSA, and we talked to this point about the need to really just simplify the configuration complexity of these identity vendor products. let's make it so that you use OpenID Connect and OAuth more than SAML because they're more secure protocols because they're resilient against certain attacks. Like, we should set the paved path towards doing the more secure thing. And I think there are plenty of opportunities and ways to do that that would be of tremendous value. So how do we move forward? So large organizations, I think, can ask themselves the question, am I valuing product quality and low defect rate in my IT purchasing decisions? Is this something I even care about when I'm buying software? Maybe not, right? Maybe I don't even consider this as a factor in making my buying decisions, but you could, right? And I think there's a way to generate demand signal there, and we've written some documents that speak to this. We call it secure by demand. When you create your own software, are you applying these concepts of safety engineering for software that you develop, if you do develop software? For smaller organizations, are there ways to band together to push for change? We've actually seen several trade associations put out letters that have basically said, hey, vendor community in such and such a sector, this thing these CISA folks over there are saying, we agree with that, please do that. And I do think, it sounds silly, but I do think that when those organizations get involved and they make statements on behalf of sectors or subsectors, that can generate more demand, right? Because individually, each of these organizations is tiny. Acting collectively, they can create greater demand signals. Have you taken advantage of free resources that exist? So for example, Scuba and the automation tool is free online. We've actually seen a decent amount of adoption by, for example, these small MSPs. So the way this tends to work with small organizations in many organizations is like there's MSPs, which are maybe themselves small businesses, managed service providers, and they will sort of offer secure, Microsoft or Google configuration as a service. And those organizations have taken our tools and then turned around and used that to help secure their customers. And we think that's great, right? We think that that is an example of trying to, do what we can within this shared responsibility model to up-level and improve the security baseline overall. And then, of course, for vendors, do you understand your cybersecurity defect rate? Is that a construct that you measure? If not, why not? Right? Is that something you should measure? If so, what are the next highest impact places to optimize? You've knocked off, FIDO internally in your enterprise environment. What's next, right? Where do you go after that? How do we optimize it? How do we make sure that we are reducing the defects in the products that we are creating? Have you committed to a culture of organizational culture security by design? And how will you think about the decisions you're making today right of boom? Often what we see is, there's not a problem. Incident happens. Oh, what do you mean? We don't provide customers an easy way to enforce MFA. Okay, we'll go back and do that, right? It would be better to do that before it happens than after. So I do think it's a good question to ask yourself, and I understand why this doesn't often happen, but ask yourself the question, okay, if I'm doing what I'm doing now right of that, even if I think the probability is low, do you trust your own evaluation of the probability such that you make those decisions in that way? And I think that's a question that's worth asking yourself. And I'll leave you with this, and then I have time for maybe one or two questions. This is a graph of US motor vehicles death rate over time. And what's astonishing about this graph is two things. First of all, the rate of miles driven is going up and the population is going up. And yet the deaths per capita are going down. So like there's two things that you multiply together that are going up, and yet the death rate is still going down because that was the power of safety engineering. We were able to make the cars so much safer that those engineering changes overcame that sort of countervailing driver. And we should be able to do the same thing in technology, at least more so than we have. So thank you.
All right, Grant, we have one question from the stream. Companies that suffered well-publicized data breaches typically don't suffer in their stock prices. What can motivate these companies and their vendors to improve anything in their technology? What can CISA motivate them to do?
Yeah, it's a good question. I mean, I think that's true most of the time, but not always. There are exceptions. I think it's worth understanding and learning from those exceptions. I think part of it is we've normalized the expectation that this happens, right? We've normalized the expectation that it's like normal course of business to have these massive data breaches. And I do think like if the scenario that I described at the beginning of the talk were to happen, I think the conversation would change probably almost overnight because it would move out of the frame of like data breaches and some abstract thing where you sign up for identity protection services where someone checks your SSN is not on the dark web, and it would move into the frame of like safety, and I think people, human beings, think about that differently. So I think part of what we're trying to say is like, hey, we're already there. We're already in many respects suffering from physical effects from these incidents. Maybe they're sort of happening below because the frog is boiling the ocean so slowly, maybe we're sort of become inured to it or normalized to it. So part of what we're trying to do is just make that point. I also think there's a community building element of it. We've seen this sort of advocacy that our political leadership has done in this space has changed the conversation on these issues in some ways. I would argue in a positive way. So I don't have a perfect answer, but I hope that for those people who agree with what we're saying, tell your friends, tell your leadership at your company. We have seen organizations significantly change in the aftermath of cybersecurity incidents without having an impact on their stock price because some executive thought it was the right thing to do, and we would like to see more of that.
Great. Well, thank you, Grant.
Great.
I think if there's any other questions, Grant can step outside and answer any questions that you all have, but otherwise, I think we're going to get ready for Allison Rosenberg's talk about passkey implementation on login.gov.